Assalamu alaikum, my dear students. I hope that you are completely fine during the situation of COVID-19. And I'm Shams Tanvir, the lecturer of English Medium Day Shift from Chemistry, and I'll be introducing you to the new chapter of first year students. So, my topic will be chapter number 1 in second paper, Environmental Chemistry. So I'll be discussing this topic chapter to you guys, and I hope that you will enjoy the topic. And if you have any further questions, you can ask me. You can email me, or you can knock me in social accounts. So first of all, this chapter is about gas and the theories and some principles of gas. So first of all, we have to know that the main difference between a gas and a vapor. So what is gas and what is vapor? So to define this, we have to learn another definition that is called critical temperature. So a gas is the form of a substance which is above the critical temperature, and a vapor is the form of a substance below the critical temperature. So the critical temperature is a turning point here. If the temperature is above the critical one, then it will act as gas, and if the critical temperature of a gas is if the temperature is below the critical point, then it will act as vapor. So we are saying that above the critical temperature, the gas will be in a vapor state, and the gas will be the gaseous substance will be in a gas form, and below the critical point it will be in a vapor form. So what will be the main difference between gas and vapor? Why we're calling it gas and why we're calling it vapor? What's the main characteristics here? So we'll know this knowledge in some uh, in the next slide. So first of all, we have to learn that what is critical temperature. The critical temperature will be that the temperature at above which the substance will act as gas, and below the point it will act as vapor. It will be called as a critical temperature. So for example, critical temperature of carbon dioxide will be 31.1 degrees centigrade. So this is a critical temperature, and above, if the temperature is 31.3, then it will be a gas form of carbon dioxide. And if the temperature is what can we say, 30.8, that is below the critical point, then the carbon dioxide will act as vapor form. So what is the main characteristics, the main identical properties of gas and vapor? We'll talk about this one. So gas, it cannot be directly liquefied, but a vapor can be liquefied under low temperature and high pressure. So we are obtaining a new knowledge here, that a gas, it also can be liquefied under low pressure, low temperature and high pressure. If we inject some gaseous substance in a container at a high pressure and low temperature, it will be in a liquid state. But for to do this, the temperature of the gaseous substance should be below the critical point, because a gas cannot be directly liquefied, but a vapor can be liquefied if we reduce the temperature and increase the pressure. For example, we if we shake the bottle of an aerosol or a body spray, we can feel that some liquid is inside the chamber. But if we spray the aerosol or the body spray, then we can see that some gaseous substance are coming out. So inside the canister, the gases are in liquid form. But if we spray the liquid outside, then we can see that it will be in a gaseous state. So we can say from this information that a gas can be liquefied in vapor form under low temperature and high pressure. So this is the main properties of a gas and vapor. We have to remember that very carefully. So we have obtained the knowledge between gas and vapor. So let's come to the next point, that is the gas laws. First of all, there is Boyle's law. So there are some gas laws which will be discussed here uh, uh, sequentially. So Boyle's law, this is a law of gaseous substance. So Boyle's law states that at constant temperature the volume of a gas is indirectly proportional to the pressure. That is, if volume, pressure and temperature, if we denote this to V, P and T, then V is proportional to 1 by P when T temperature will be constant. So the mathematical explanation we can see here that for multiple gases we will obtain this equation, and this equation will be useful for further mathematical problems where we'll be solving some mathematical problems for all the gas laws present in this chapter. So the equation derived from this mathematical explanation is for multiple gases, that is the product of pressure and volume will be equal to a constant K. This is the mathematical explanation of Boyle's law. So Boyle's law basically states that when temperature is constant, volume, if pressure increases, volume will decrease, and if pressure decreases, volume will increase. This is the verdict of Boyle's law. So we have learned Boyle's law, and then let's come to the next law, that is Charles law. So Charles law tells about the condition of a gas at constant pressure. So at constant pressure the volume of a gas is directly proportional to the temperature. If temperature increases, then volume will increase, and if the temperature decreases, the volume will certainly decrease. So we are seeing that V proportional to capital T when pressure is constant. So this is the derivation of Charles law, and from mathematical explanation we can see that ratio of volume and temperature of multiple gases will be a constant K, and this equation will be useful to us when we solve some mathematical problems. So this is the Charles law. And then next one, Gay-Lussac's law. So Gay-Lussac's law states that at constant volume the pressure exerted by a gas is directly proportional to the temperature. Here we have to carefully describe the law, because the pressure exerted by a gas and the atmospheric pressure, it's not the same. The atmospheric pressure and the pressure exerted by a gas, this is an individual pressure, and the atmospheric pressure is the pressure of a system, of the surrounding. So these two pressures are not equal, and the pressure exerted by a gas, it is also called vapor pressure. You can search in the internet about this vapor, what is the vapor pressure. So the vapor pressure means the pressure exerted by a gas or a substance, this is called vapor pressure. So if volume is constant, then if we increase the temperature, pressure exerted by a gas will also increase, and if we decrease the temperature, the pressure exerted by a gas will also decrease. And from mathematical explanation we obtain that the ratio of pressure and temperature will be a constant K for multiple gases. So this is another equation obtained from Gay-Lussac's law, which will be utilized for the upcoming mathematical problems. So we have seen Gay-Lussac's law, then let's come to the next law, that is Avogadros law. The Avogadro number you have already read in many topics about Avogadros law, and you have solved many mathematical problems during your secondary syllabus, secondary examination. So Avogadros law, it will be like this, that at constant temperature and pressure. So first, please keep in mind that in Avogadros law both the temperature and pressure will be constant, but in Boyle's law pressure was constant, in Charles' law temperature was constant, and in Avogadros law both the temperature and pressure will be constant. So at constant temperature and pressure, the volume of a gas is proportional to the number of moles. Here we can see that a new term is coming, that is number of moles. So when will the number of moles will be directly proportional to the volume? When pressure and temperature is constant, then the volume will be proportional to the number of moles. If number of moles increases, then volume will also increase. If number of moles decreases, volume will also decrease. So this is the verdict of Avogadros law. There are some mathematical problems regarding Avogadros law. We'll solve this in the next video class, which will be totally for mathematical problems. So now let's come to our next law, and this is the last law of our topic, that is combined gas law. This is basically a combination of Boyle's law and Charles' law, nothing else. So combined gas law, we are combining two gas laws, that is Boyle's law and Charles' law. We are getting two relations. This is a relation, this is not an equation. Please keep in mind, an equation is a uh, is the expression when both left hand side and right hand side are equal, but uh, in this section, in this relation, the left hand side and right hand side, they are not equal. This is just merely an expression of ratio. This is an merely expression of ratio. If one increases, another variable will decrease, and if one variable decreases, another will increase. So the relations are like that. So if we look at the left side here, there is a v on both sides, that is v will be common here, and relations can be written like this, that is product of both the right hand side. If left hand side is common, then we can write the right hand side the like products. Okay, so if we combine the both the relations, then we can uh, say that this is the final verdict of mathematical explanation. Then we are saying that pressure, volume, and divided by temperature, it will be like a constant K, and for multiple gases the product of pressure and volume and the divided by temperature will be a constant K. So from this we obtain a new equation, which is the combination of Boyle's law and Charles' law. This is called combined gas law. So these laws are very important for obtaining some valuable information and expressing the mathematical terms and solving mathematical problems. This is the laws are applicable in every aspect of the gases, how they work, how they uh, expand, how they compress. So these form laws are basically a summarization of the all the activities of a gas. So these gas laws are the fundamentals of the acting principle of a gas. So that's all for today. I hope you enjoyed this video, and if you like this, you can give your feedbacks, and if you cannot understand something, or if you have some specific questions, you can also ask me. So that's all for today. Well, thank you very much, and see you next time. Allah Hafiz.